Welcome back, everybody. Today we're joined by Dr. Varun Dwaraka, Director of Research at True Diagnostic, where he's cracking the code on aging through epigenetic biomarkers. His work, featured in Natural Aging, Forbes, and the Emmy-winning documentary You Are What You Eat, is reshaping how we think about health and longevity. Dr. Varun, how are you today? It's good to have you.
Greetings.
Man, this is great, guys. Yeah, nice to meet you all. Eric, he's actually my neighbor, so this is kind of cool that I didn't realize you do this, so thank you, guys. And Aram, nice to meet you both.
Yeah,
good to meet you as well.
It's going to be a blast. We're going to jump into some fun icebreakers here, so I'll head us off, and then we'll spend a little bit of time here. Tell me, Dr. Varun, what is the most memorable place that you have ever traveled to?
Oh, wow. Yeah, I've traveled to a bunch of places. I think the most recent one, I went to Kauai, and Nepali coast is incredible.
Nice.
It's, the way that they've taken care of the land, especially there, and just being able to, just go off the coast. We saw it from the helicopter and also from the boat. It's just
beautiful.
Pristine. Yeah.
Oh, wow.
Beautiful.
Okay, here's another one. If you could have an unlimited supply of one thing, what would it be?
Dang, patience. Patience. If it has to be, I don't know if it had to be physical or if it's like something, but patience, man. I mean,
that was a very noble answer anyway. So we're going to give you points on the vote.
Definitely.
I'll be honest. Today, I had, especially working in this field, man. Like you start working with a lot of like physicians and stuff, and so this is where I feel like patience really helps when you're trying to talk to someone who may not be getting it but thinks they're getting it. So yeah.
So, next question. Who would play you in a movie about your life? Like your biopic, who's doing it?
Who's the guy from Slumdog Millionaire? Dev Patel?
Nice.
That's good. That's a good one.
Fantastic
Strong.
actor. Oh, man. Yeah.
It's great. That's good stuff. Good stuff.
Okay, well, let's go ahead and jump into it. For the listeners who are new to what you do, could you explain basic, like, if it was like a fourth grader type level, what you guys do, why is it exciting, and how is it, why is it important?
Absolutely. So I work for a company called True Diagnostic. What we are trying to do is empower individuals for better understanding their biological age. Now, everyone understands their chronological age, the age based on the date of birth. And I think that idea has been used not only just to, tell you how old you are and, are you an old boomer or are you a young Gen Z guy or girl, like whatever that is, but there's actually medical affiliations with how old you are, because as you grow older, you tend to have more age-related diseases. And a lot of diseases actually just pop up as you get older. But if you've ever looked at certain celebrities or people and you're like, wow, I think that person is 30 years old, but they're like, no, I'm actually 50. And you're like, what the heck? Like, how do you look something different than your chronological age? It's because their cellular age or their biological age is actually much more optimized for that particular age. Yeah. And so what we do is we've actually figured out a way to tell you how old you are biologically, and then be able to give insights as to what that means in terms of, your risk of disease, your comorbidities. If a fourth grader understands the word comorbidities, then holy crap, like that's amazing. But I'll just put it out there. Yeah, there you go. If you're a fourth grader, look that word up. It's gonna be great. But yeah, like understanding the diseases that you're maybe affiliated to or affected by. And so we empower individuals to better understand that and then make choices based on the recommendations either we give or the physician that uses our test would give.
Can you give us a little background? Like, why did you get into that? Have you been in this field for a minute, or was there something that kind of spurred you into this specifically?
It was honestly perfect blend of mistakes and also just being there at the right time. I'm a native of California, so I grew up in actually the Silicon Valley in Cupertino. And so, I think a lot of my upbringing was around technology, and I mean, science was kind of a thing that, especially having Indian parents, it was one of the accepted natures that I could kind of follow, like in terms of what I wanted to do with my life. And so, like, seeing that blend, especially in Silicon Valley, and then where I went to school for undergrad at UC Santa Cruz, University of California, Santa Cruz, I actually fell in love with the technical side of things, using bioinformatics and using data analytics to solve biological problems. So when I did my PhD here, I actually did it in regeneration biology. And one thing that people don't really understand is that if you're trying to understand how, let's say, tissue regenerates, which is what my PhD was on, there's an aspect of regeneration, which is the aging process. You not only have to recreate the tissue that is lost, but you have to age it in a way so that it comes back to what it originally was. And so in that concept of aging was where I started to kind of look into, okay, this is a fascinating area. And after my PhD, I thought that I was going into academia as a postdoc and ultimately a tenured professor. But there was a small company in Lexington, of all places, called True Diagnostic, which just started at that time. And they needed somebody with the hard skills of coding and data analytics and everything, but also the soft skills of actually understanding the aging aspect and also the biomarker that we study called DNA methylation, which was a large portion of my PhD work, just understanding that biomarker. So I honestly, at that time, it was a small company. I kind of dove in, really loved what they were doing, the idea, the concept. It was backed by really good science, which is actually very important nowadays, especially when you're in biotech. And then 3, I think from a startup perspective, because I think I might have been like employee number 4, you really need to you need to understand that the founders that are there love what they do and are good at what they do. And I think the perfect blend of all 3 was there, and it seemed to click, and you kind of jump in, and it seems to be working out pretty well.
What was it like to be in a startup of only 4 people?
It was yeah, those early days, it was a fire pretty much every day.
Sounds like a startup.
Sounds like yeah.
And I think everyone dramatizes it. It is like, even though I say it's a fire, it's just essentially like something you have something that you want to work on that day. You prep and do all that, but it's never what you end up working on for the rest of the day. Something pops up, you have to fix it. It's very reactionary because a lot of times you don't really have a person that you can delegate it towards or whatnot. You have to be the expert in your domain and a little bit extra as well. And so it was very stressful during those times, but I felt like I was learning so much. You're drinking from the fire hose. I think your creativity is actually working at the max. Like, you're trying to figure out, I don't know anything about, like, I'm not a physician, so I don't know about like reactionary medicine, but I got to learn it. I got to figure out how to communicate these ideas and how do I develop tools to kind of fit within that. That's not what I did my PhD in. So it was all of that.
So you guys basically go to the molecular level, and is it like, how does the tests work? I mean, is it just blood work, or do you guys do like, explain a little bit about that? And is it just, do you guys give an average of your age, or do you go in more detail in like, your liver is this, your heart is this, and those sort of things? Can you explain that?
Yeah, absolutely. A fantastic question. So it's actually very similar to your blood work in the sense that we are, calculating all of this from your blood. But the difference is, in majority of the times when you go to your clinic, let's say you're doing a clinical test, you're doing a lot of these panels that are based off of proteins, your IL-6, CRP, that are all like proxies for inflammation. What we realized, and it's not only just us, we stand on the shoulders of the giants, a lot of the academic area that really built the science up, what they started to notice is that if you take the blood, you can collect that using just a regular finger prick test, so very similar to like a glucose test. You can quantify DNA methylation. This is the biomarker that's on your DNA, and essentially it's either on or off. And based on that orientation, it actually impacts how the genes are being regulated, or the genes, basically the portions of your DNA that are actually coding for, let's say, a protein. And that eventually is the biomarker that does all of the work in your molecular biology, or majority of your molecular biology. If you use the DNA methylation orientations, what people have realized is that a lot of those orientations are highly correlated to your cellular age. And so it's essentially a blood test using just a finger prick. You can we have a kit that you actually can buy online and has been available for the last few years. And it's direct to consumer, and or you can work with a physician who can order it. So it's very much like a 23andMe test. You can just get all of that, and you could do it by yourself at home. The kit's really easy. Once you put it on a blood spot card, it's essentially literally just a card you could put your blood on. You send it over to our facilities, and they're actually based in Lexington, Kentucky, over on Corporate Drive near Beaumont.
Oh, wow.
So
I love that.
You could send it over to the labs, and we actually have the entire place retrofitted for this particular machinery that's able to read your DNA methylation. Goes through that process, then comes over to my end, where like the team that we've built out to support the bioinformatics, which is what that's where I really started for the first 4 years, which I built out, and also the team. Then it goes into analytics. It gets all quantified, all the measures that you can get, and I'll explain some of those. And then it just comes back as a report. So we'll tell you it's done. Here's a slew of biological ages, and I'll explain why there's a slew, like multiple. But then also we'll do your traditional blood tests from the same data set. So from a single, let's say, from a single blood spot card, or the blood prick, if you will, you're getting over 600 blood measurements that include your typical CRP IL-6, but your biological age measures and all of that as well.
Okay.
Now,
that's crazy.
Dang.
Yeah,
Wow.
it's been a lot of work. It's been a lot of machine learning, which I can explain as well.
Yeah,
But
I wanted to get into AI and how it's helped you guys.
Yeah. But I do want to say there was one question. I think the question was, what are the measurements that you're getting, and why is it just like multiple? It's because if you think about aging is a very complex procedure. It's not just you're aging at multiple different biological pathways. And so just like your clinical test, you're not going to take a, like, let's say, glucose test to check for inflammation, right? You're going to have your own set of panels for that, and then own the same kind of panels for this. It's the same thing with biological aging. Multiple, what we call epigenetic clocks or biological clocks, capture a different portion of aging that's maybe due to more, instantaneous aging, or your odometer, how long have you existed in this world, and captures a lot of those signals. And so we're actually giving you every single one of those measures, so that, and this will go into the AI part, so that could drive an AI engine to get more of a specific, let's say a more, not a composite, but more individualized measurements, so that it's actually driving it in a more specific way.
Especially over time, if you take the test multiple times and you kind of keep up with it, right?
Yeah, exactly. Nail on the head. That's the beautiful thing about everything that we're trying to do, is because a lot of the biomarkers with DNA methylation, it actually is very in tune with your exposures. Biologically, it makes sense because the way that your body or your cells have kind of figured out how to react to your environment is through this biomarker. So why not have a test that is actually capturing your environment, rather than something like your predisposed diseases, like a genetic test, right? So that was kind of our logic with why we focused on this, rather than doing something like what 23andMe did with their genetics, right? Your genetics are not going to change as you grow older.
Sure.
But your methylation will.
So I've got a question. And I know we definitely want to dive into the machine learning aspect of things. I recently I've gotten into like extended water fasting, and so the process of autophagy they've said can have an effect on that biological age. Have you seen that in your work? I mean, obviously, like a lot of that's bro science, and like I'm really heavy on the fasting subreddit on Reddit, but
Sure.
I know that in my own experience, just a lot of the like medical issues I've had, I've done an extended water fast, and a lot of that has gone away. So I'm curious how that affects with if you've studied the impact of that in your own work, or just curious about it on your own.
No, absolutely. So the thing about bro science is that it's actually kind of great. It kind of gives like a little bit of a hypothesis that you can then test. But to your point of fasting, just in general, there was a study done by Dan Belsky's group out of Columbia University now. They actually looked at a caloric restriction, so not even a full fast, but just 25% caloric restriction from their daily calorie intake, which I think was set at around 1,800 kilocalories to 2,000. If you just reduce it by 25%, in about 2 years, they saw significant decreases of essentially your biological age based on this one biomarker called pace of aging. That pace of aging marker is actually highly associated with disease outcome measures such as diabetes, cardiovascular disease, and all of these other disease states. And so there is some level of science that fits that bro science, that you do see that based on these measures in general, like so these epigenetic measures, you do see improvements based on this potentially fasting and caloric restriction in general. Now, the reason why is still up in the air. We're still trying to figure out, is it a reaction, or is it that based on the fasting, are you seeing the improvements, or is it some other metabolic improvements that are happening that's causing that? But overall, it seems like those two are actually pretty in line. We also did I think that there was another study. We did a study on HIV specific individuals that were taking semaglutide. And typically what we see is that a decrease in calories, especially in this study and another omnivore and vegan study, which I'll explain as well, anytime that there's a reduction in calories, there tends to be an improvement or a decrease in that biological age. So I'm wondering
eating
if it's
one meal a day.
It could be
basically
eating one meal a day.
That's basically what I do.
Yeah, you could do that, or you could even do like just a caloric, just managing the calorie intake as well. So, yeah, I typically will eat in the morning breakfast. I'll kind of do a light lunch, and then dinner is a little bit lighter. I definitely have changed my habits based on some of the stuff we've seen.
That's what I wanted to get into too. Is like how have your own personal habits of and view of health in general for you personally have changed based off of. I mean, have you taken the test for yourself?
Yeah, I have.
Okay.
We're
abysmal.
definitely going to have to edit this if he said no. It's like, so sure.
Yeah, I don't believe in this.
That was not going to get aired.
No, it's I've taken it, and I was actually terrible in my age. Like, I'm not gonna lie, I was like, I think I was 8 to 10 years older biologically than I was chronologically at the time.
Wow.
And it freaking sucks, man. Like, you see that, and you're just like, and at the time I was lifting a lot, and I was like, I thought I was in good shape, but cellularly, I don't think I was. But what it's kind of taught me was, going back to the literature, which is a good thing about what I do, is I'm pretty in tune with the literature associated with these measurements. You start to see that diet has a huge impact. So high polyphenol content based, foods have a huge impact. Caloric restriction tends to show a positive improvement in a lot of these epigenetic clocks. The omnivore and vegan diet paper was actually a first author paper from our group. And we did this with, this is what actually got onto that Netflix docuseries, You Are What You Eat, where they followed a vegan and two essentially sets of twins And one set of twin was on a vegan diet, one was on an omnivore diet, and within 8 weeks, the vegans were showing significant decreases in biological age compared to their twin counterpart in just 8 weeks. Now, is that because of the diet or the caloric restriction? That's still up in the air, but there was still an improvement. So it's got me thinking about, maybe caloric restriction and using something like a vegan diet in moderation, at least for the 8 weeks. That's something I have employed. Alcohol, cutting that out as much as I can.
I was trying to hedge you off with the past there, but okay. I was curious, like to take that a little bit deeper. So if someone does this test, obviously that is one set of data that you're supplying. Are you able to offer much in the way of prescription? Because we're talking about like caloric reduction, all these other things, right? I think there are some like broad level things that can apply to everybody. Like applying to everybody, lower alcohol consumption is going to be a net positive, right? Like I don't think there's that many people where that's not going to be the case. Like there are some obvious, but maybe a little bit more specific to the individual and their particular genetics. Like, are there certain things that you're able to say, hey, for you, for all these different things, like you're going to have to adjust and tweak these a little bit more. Are you able to do that at this stage, or does it still have to
like
be
a
more
personal
broad?
pill or something?
Yeah. A personal thing. No, I think so. We've actually purposefully stayed away from the pharmaceutical side of things. For us, we noticed that there was a gap in the data analytics that were coming with epigenetic testing in general. So for us, in our mind, it didn't make any sense to start offering something if you didn't understand the data that was being generated from a human specific level. Now, this is kind of where the AI portion starts to come into play, because the biggest thing for us when we first started was generate a data set that is actually very encompassing and represented a larger population of individuals. So we've done this within our own cohort. So now we have about 80,000 individuals that have full methylome sequencing, which is the largest in the world at this point. Awesome. In order to develop some of our other products, we've also collaborated with Harvard University. So my collaborator over there runs the Mass General Brigham cohort, essentially a biobank. We've taken some of those samples, we've done all of our biological quantification and developed these models. In this next phase, what we've done is that using all of this information in the context of diseases, we're able to feed it into an LLM or some type of AI generator with the context that has been generated throughout centuries of just medical literature, right? Because the way that we're building a lot of these, especially not just in the context of clocks, which the epigenetic clocks are fairly new. The first one really came out in 2011, so not much has been really shown. But I'll also explain that that's actually part of my role now as director of research. But there's an entire aspect of methylation that we're using called epigenetic biomarker proxies, where from the same exact data set, we've built models to model what your CRP would look like, what your IL-6 would look like, what all of your VO2 max, all of these different measures that you typically get from the clinic. We validated it to make sure they work very similarly, if not exact. And then now we can harness all of the literature that's already there through these LLMs. Because, these LLMs are taking in, I think there are a few LLMs that are very specific that are taking in case notes. They're taking in medical. The Lancet produces a lot of case studies, and we can now harness that information in the context of all these data, and then be able to now, kind of what you were saying, Aram, be able to produce more specific, individualistic kind of reports for them.
Like recommendations, kind of like low on vitamin K or something like that.
Exactly.
Basically.
And we also again are there to empower the physician, because we don't think physicians are going to be replaced, like this whole pocket MD idea. I personally don't believe that's going to be the case. What AI in this case will do is maybe pinpoint a little bit more of a narrower hole, so that they can spend their time focusing on the complex ideas rather than the general, just quit drinking, man. Like,
Yeah,
what are you doing
exactly.
with yourself?
Yeah.
Yeah.
So, with continuing into machine learning, like, how did that, beyond your work, how did that power the eye-opening 2025 study on semaglutide or Ozempic potentially reversing the biological age? Like, what was when you think about that, what was the biggest surprise there? Like, what kind of like, oh wow, we didn't expect that.
Yeah, that's a good one.
Yeah. First of all, I thank you for reading that. It seems because that was a very good question. It's always
job,
cool
yeah,
to. It's always cool when somebody reads the papers. I don't know who's reading.
We're a very erudite set of podcast hosts.
Yes,
like
we
to know our
are.
research.
Yes, we are.
I appreciate it. And I think it goes to a little bit of what my role is now, right? Like when I first started, I was in bioinformatics, building all the data analytics, and actually doing a lot of the machine learning. Now we have a fantastic crew that handles that. But one of my questions was, we've created all these models. Where do they work? Where do they not work? So half the time, my work, or actually majority of my time, is to be part of these clinical trials where we go to people that are running these studies. Like that was with Michael Corley from UC San Diego, who's a fantastic collaborator of ours. He has an interest in methylation, but doesn't have the models. So as long as he has blood, we can help them run their study, introduce these models there, and see if, for example, does semaglutide have any effect on these epigenetic clocks? It's not that we came in thinking that they would, and we just wondered if it would. And that's where that paper was really it shocked me, and I find myself getting shocked a lot, is that the number of epigenetic clocks which are capturing various aspects of aging did decrease, even though these were HIV specific people.
Wow.
And it was a comorbid kind of population. It's still, we did this in a randomized control trial, so there was a placebo, there was a semaglutide GLP-1 agonist, and we saw significant decreases in one arm but not the other. Same thing with the omnivore vegan trial. Actually, me and the founder were taking bets that the omnivore would do better because vitamin B12
I
is
would have
actually
thought that too.
Yeah.
Same.
Yeah, the vegans are notorious for having low vitamin B12, but it was the opposite. So, so to your point, I think it's a lot of the times when we run these, we're coming in with, especially from my perspective, I come in with a blank slate. I like to let the data kind of let us know. I know clinical trials, they have primary outcomes. They're already coming in with a bias saying like, we should focus on these LDL measures or whatever. This is a personal take. I don't think that's how we should be doing stuff. We should be letting the data dictate everything. But I'm not going to fight the AMA on this.
Perfect world scenarios, right?
Yeah, exactly.
I had someone, kind of a professor, what you say, like, in a perfect world where the grass is green, the birds are always singing, we'll do X. And he's like, but since we live here,
I will be using
exactly.
Yes. Since we're living here, not everybody has an iPhone. They use Android. Okay. So real quick, I'm curious, like, if you're, one thing that I always like to look at when I'm talking to somebody who's like an expert in something, and obviously you're like pretty deep in this and what you're talking about. If you're looking ahead, what do you see as particular challenges to your field? So it could just be constraints against trials, right? Like that, that's something you already mentioned. Like, hey, is it just kind of trying to look at data for its own pure sake without the bias on top of it? Are there things specific to what you're doing in particular for these epigenetic biomarkers? So what are your, maybe the outset, like 10 years from now, what do you might be some of the bigger challenges and possibly some of the more significant outcomes, significant breakthroughs, in like if things go super, super well?
Yeah, no, it's been, I think the immediate kind of coming off of the joke earlier where it's like patience, it's getting everyone up to speed, right? Like it's the education aspect. This is, so what I mean by that is epigenetics is a very relatively new field in clinics. Like from a biologist perspective, people have known about epigenetics, especially DNA methylation, since 50s. And and so like from a biology perspective and gene regulation, all of that makes sense. But in the clinic, it's really hard to kind of, teach that. The other thing too is that sometimes, the way that we've developed our EBPs, is the epigenetic biomarker proxies, is to mimic that of the CRP or IL-6, which the physicians already know. But what we've been seeing is that there's actually discordance as well, because sometimes if you think of it in a linear perspective, proteins change much slower than the DNA methylation does, and proteins are a reaction to what the DNA methylation is capturing from the exposure, right? So explaining that difference, especially when those values don't match, is very daunting. And sometimes they see it as, hey, you're actually giving us, fake outputs. It's like, no, they're not fake, but they're an other aspect of biology which we just haven't understood yet. So I think that's the hardest, is education, and then also having the scientific claims to back it up. There was a famous company called Theranos, which also offered single blood prick to do a bunch of tests. And I was like, once the dust settled, when we hired more people, I was like thinking about this, and I was at existential crisis. I was like, shit, are we Theranos? Because that's kind of what we're trying to do. But I would like to think, I mean, I'm working on the turtleneck already right now.
That's great.
But one of the things I've been trying to at least focus on, which is why the director of research really makes sense, is that we need to be able to publish this. We have to be able to face the scrutiny of the peer reviewers. And I think that's also a challenge because, a lot of the times the science is really, really good. How do you translate that into clinical sciences? And so that's another thing. And then number 3, I think in 10 years is, how do we make this more accessible, right? It's a $500 test. In order to do that, we're at the whim of certain manufacturers who create the chip and the reagents that are being used to actually do all the sequencing the quantification. And so, how do you reduce those costs so this becomes available to everyone versus just the high income earning individuals who are probably already healthy? So I think that's another thing that we've been thinking about, is accessibility.
That's cool.
Yeah. And then that fuels the data as well, because if you make it more accessible, then you're going to have individuals.
True. Everything loops together. Yeah.
Better sample sizes. Sure.
I would love to have more representation of South Asians in our data set. We just don't So that's another thing that I would love to have represented.
Yeah. Do you see a good intersection for pop culture and scientific findings? Because I feel like, at least growing up, and it's a little different now, but I feel like growing up, it was almost like, to really understand things that were important, you almost had to be a nerd. It just wasn't cool, to actually know useful information. And that's not actually one reason why I really like Neil deGrasse Tyson is a good example of this. He's everywhere. He's super approachable. He knows how to break things down. But the guy knows what he's talking about. He's not just making this up on the fly, right? He's pretty on top of things. So I'm curious, just as your approach, you're obviously younger, and I'm just curious if you've seen that kind of intersection and maybe what kind of importance might be there, just a take on that.
Oh, it's hugely important. I think that I think the reason why there's been so much flack, I guess, even from a government perspective or pop culture perspective against science, is that it's too hard to understand. I think that if you think about exactly the person that you shared, Neil deGrasse Tyson, Bill Nye the Science Guy, all these individuals, they broke science down to make it accessible, but not to dumb it down, right? I don't think you should be dumbing it down. For me, I actually experienced this a lot during my PhD, where you were essentially touted to explain things in a very the vernacular had to be exact, it had to be verbose, it had to be you're talking to a bunch of if you dumbed things down or made it accessible, they'd be oh, you're now thinking I'm stupid or something, which is not the case. And so and so when you're trained like that, it's a muscle when you start to go into the public, that you keep like remembering it, and then so being able to break things down in a more accessible way becomes another muscle. And I had to train myself significantly in the first 2 years, because one of the cool things about, again, a startup life is that you get to do things that you're not necessarily hired for. This public communications was another thing that like kind of came out of it, because that's what the company needed. You needed to be able to explain this to physicians, to direct to consumers, to people that were buying the test.
Yeah.
So I think that, having some level of like popular science communication, understanding how much you don't have to break down versus how much you have to be able to rephrase in a way that people find anchors of people's understandings. I think that's very important. Even in this podcast, I'm pretty sure I might have said something, and some guy that's in aging is like, "Oh, that's like, what the hell?" Like he didn't hit that particular like.
He didn't even mention that.
I'm already, yeah.
You're gonna get an email.
Yeah, I'm gonna get an email. They're like, he's like, "Are you even a doctor?" It's like, stop, Dad.
So how can if listeners want to go get the test, how can they find you? What's the website? That kind of thing.
Yeah, absolutely. So you can buy the test from www.truediagnostic.com. So trudiagnostic.com. It's available for direct to consumer, so you can literally buy it. It'll ship over to your place, and then you could just ship back the blood samples. You could also work with longevity doctors or functional medicine doctors. A lot of places around the world. We are international, so you can actually buy it or go to a physician and get it. And then
Cool.
there's also another company, or it's also an app called Infinite Epigenetics. They've partnered with us to create the LLM. So once you get your results back, you can actually upload your PDFs to that app, and it'll actually use the back-end LLM that was developed to kind of give you more of those insights. And so we've already done a beta run. So it's in kind of like beta testing mode. And I think that it'll be, this app will probably be released in the next few months. So look out for that as well.
Sweet.
Cool. What was the
That's
name of the app
awesome.
again?
It's called Infinite Epigenetics.
Okay.
Okay.
Yeah.
So, Varun, how do our listeners connect with you? How can we reach you? I mean, I know we've got the company site and everything, but you've got the unique ability. Like, we know you're super intelligent. It's very clear. Like, you talk to you in 5 seconds, we know you're brilliant. But you also have the way of like breaking it down, communicating it in a way that the average person can understand. But at the same time, it doesn't, like you said, it doesn't dumb it down. Like we understand it. It's the scientific concept. It's clear. But so how do people reach you? How can we connect with you?
Yeah, absolutely. Thank you for that, by the way. I don't feel like I'm smart. I think I'm hardworking, and I think it's led to knowing certain things. There's two ways. So my professional way to connect, if you're, let's say, in research and want to take part in this, it's LinkedIn. So Varun Dwaraka, if you just go to LinkedIn, you'll see me there. But I also have an Instagram page. I use Instagram. Well, I used to use it just for personal reasons, and pseudo-personal now is for that exact reason. I think that we're publishing a lot. We've published about 15 papers in the last year. And what I try to use that for is a way to disseminate what that paper, why did we spend the last year on this one paper? And explain what that means. And so Instagram is usually the way that I kind of go about it. And it's still very simple. Varun Dwaraka, no spaces, no capitalization, just no BS, as I like to put it. So yeah, connect with me on there. I usually post a lot on, True Diagnostic, our research, and then also other podcasts I've been in. So hopefully you find that as a resource.
Absolutely.
Nice.
Well, it's been a ton of fun. Thanks so much for coming on the show today and teaching us all something. Look forward to staying connected with your work and what's coming down the road. So hopefully we get to do this again.
For sure.
Yeah, I appreciate it, guys.
a lot
Thank
of
you.
fun.
Eric, shout out, man. Thanks. This was fun, dude.
Yeah, we should have you on again when you have another breakthrough or something. We can talk about it.
Yeah.
Absolutely.
Yeah, absolutely. Absolutely.
That's awesome. Well, thanks, Dr. Varun. It's been great. Hope you have a wonderful weekend ahead, and we will catch you down the road.
All right. Thanks, guys.
Thank
All
you.
right, cheers.
Cheers.